Welcome to geometry, guys. All right, so today we're going to be going over the lesson of transformations in the coordinate plane. All right, transformations in the coordinate plane. Today we talked about the three different kinds of rigid motions. All right, we have rotation, reflection, or translation. The first one is a rotation, second one is a translation, and the second one is a reflection. Although you might think it's a rotation, it's actually a reflection, okay? And that's the line of reflection. And lastly, the final one here, you have a rotation. Notice that F is actually down here. So this is F and this is F prime. Got it? Okay, so that's a rotation. If we go on, we notice that we have a new word here. We know that a transformation that preserves size and shape is called a rigid motion, but it's also an isometry, okay? So isometry is also a transformation that preserves size and shape. That's also the definition, okay? The same thing as a congruence transformation. So if I ask you, give me a congruence transformation, you're going to say reflection, rotation, or translation. Same thing if I ask for an isometry. We know that a dilation is not an isometry, right? It is not a congruence transformation and it is not a rigid motion. We were working on the coordinate plane and we need rules to work on the coordinate plane because so far we've been doing transformations with compass, straight edge, and rulers. But today we're actually going to work with the coordinate plane. Notice that I have a pre-image and the same thing, I have an image. But how do I get from my pre-image to my image? Well, that's why we have these expressions to help us find our coordinate points. This will help us find x, and this expression will help us find y, the one that's written in here. Okay, so moving forward, a transformation is sometimes, this is sometimes an isometry. Why sometimes? Well, because we have four different kinds of transformations, but only three of them are isometries, okay? Only three of them, namely the rigid motions. Lastly, we have that rigid motions produce blank images that are congruent to pre-images, while rigid motion preserves size and shape. So it always, okay, always produces congruent pre-images. And this is where people got stuck today, okay? Well, I have a point and I have a rule. This is the rule. How do I go from my pre-image and get out an image? Well, the image in this case would be A prime. How do I find A prime given that I have this rule, okay? This rule, it says you have A, you dump it in here, and you get out A prime, okay? So this rule says that if you have 0, -3, and I'm looking for A prime, then all I have to do is substitute, right? 0 plus 3 is the same plus, and then y minus 3. But what is y? Well, y is -3. Actually, I made a mistake here. Sorry. You get -3 minus 7. Okay? So what is 0 plus 3? Well, 0 plus 3 is 3. And -3 plus 7, -3 minus 7 is -10. Okay? So what is A prime? Well, A prime is 3, -10. And I'm done. But this time, I'm asked to work backwards for letter B. I'm asked to work backwards. I have B prime. It should be a B prime. And I'm looking for B in this case. Well, this arrow only works when I'm finding B prime. So this arrow actually has to go the other way around. Okay, has to work backwards. How do I go back? Okay, So this time when we say, okay, I have my image, what is my pre-image? Notice that in this case, x plus 3 had to give me, x plus 3 gave me the 3. And y minus 7, that's the thing that gave me the 10. So I know that this needs to produce the result. So in this case, it's the same thing. X minus 2 has to give me 5 because that's my image point. This has to give me 5. And 3y has to give me 9. Okay? It has to give me 9. So what is x in this case? Well, simply solve. Plus 2 plus 2, x is equal to 7. Okay? In this case, divide by 3, divide by 3, y is equal to 3. Okay, well then what's my point? B is 7, comma 3. How do I check if this is correct? Well, remember how we did it in part A? Now I'm looking for B prime. How do I check if this is correct? All I have to do is go forwards this time. Well, B is 7, comma 3. So 7, comma 3, working forwards, would be 7 minus 2, comma 3 times 3. And 7 minus 2 is, voila, 5, comma 3 times 3 is 9. Yes, it did work. That's exactly what I wanted right there. Okay, this is B, and this is B prime. Great. Let's move on to the next. In this case, I have this rule, and these are my pre-image points. I need to locate my image, plot the image, and determine if it's an isometry. Again, determine if it's a rigid motion. Determine if the size and shape stay the same. So let's work according to our rule here. So our first coordinate says, well, I know I need to go forwards because I'm looking for A prime. So this rule is going to work for that. So I say 2 times, using the first coordinate point here, A, 2 times negative 3, comma, y is negative 4. So negative 4 plus 7. Okay, 2 times 3 is negative 6, comma, negative 4 plus 3 is 3. So the first point that I have is negative 6 and 3. The second point would be B. Well, the same thing. Let's apply the rule to B. B would be 2 times negative 2, and then comma, using the rule again, y is negative 1 plus 7. You should try this on your own and just use the video to check your work. I get here negative 4, comma 6. And so this is negative 4, comma 6. Lastly, I'll do the rule for C. C says 2 times 2, comma, negative 4 plus 7. And so I end up with 4, comma 3. And so the rule says that C prime is 4, comma 3. Now, I don't really know if this is an isometry right now because I have points that I don't know exactly how the picture looks like. So I need to look at the pictures, this picture and this picture, to notice what actually happened. So let's plot our first point. Negative 6, 3 is actually right here, okay? This is called A prime. Let's find B prime. Negative 4, comma 6 is up here. This is B prime. And finally, 4, comma 3 is over here. 1, 1, 2, 3, 4, 1, 2, 3. Here it is. Okay? When I connect them, I end up with this picture. Hey, that looks weird. Is this a rigid motion? Doesn't look like it because the picture got, what happened here? Well, it got bigger, right? It got bigger. That means that this was a dilation. Is a dilation in isometry? No, it's not. So, is this in isometry? Absolutely not. Going on to the next page, you guys can try this one on your own, okay? While I'll do the other one. Actually, I'll do this one. The rule here says negative y comma x. Well, that means that if I have the point negative 6 comma 1, I gotta switch them. I gotta switch these. Okay? So that means that the 1 goes here, but it says that it's a negative y. So it has to be negative 1. And keep the x. Do nothing to x. Okay? Same thing on the second time. Well, I have to take 4 and place it here. Okay? But put a negative sign. Okay? Let's do C now. Okay? C prime. Well, C prime says take this 1 and put it at the y, but negate it. Okay? If I'm looking at B prime to find the y value, all I have to do is take negative 5, and that becomes my y value, and negative 1 becomes my y value. Okay? Is it an isometry? Again, I have to plot it and determine if it's an isometry. Okay? So take negative 1 and negative 6. Right? This is A prime. Go negative 4, negative 5. Here we go. And negative 1, negative 1. Here it is. Is it an isometry? Well, what was it that happened? Here we have A prime, this is C prime, and this is B prime. What was the transformation that happened from ABC to A prime, B prime? Is the shape and size still the same? Yes. Yes, they are. And what was the transformation that occurred? Well, notice where C prime is this time versus A prime and B prime. It was a rotation. So of course, it is an isometry. For this last one, this is where you guys need to do the independent practice, okay? If I need to translate 2 units to the right, okay, what does that mean? What is changing, the x or the y? Because I need to come up with a rule here. I need to come up with a rule. What is changing, x or y? If I'm moving to the right or left, x is changing. So that means this is going to say something with x. And if I'm moving to the right, I'm adding. So plus the 2. And now finally, 1 unit down, well, that's the y. And if it's going down, it means I'm subtracting 1. There is the rule. So on the pre-image side, you're going to write all the pre-images, which are right here. What is A? What is B? What is C? And so A, I'll give you all of those coordinates. A is 4, 3, negative 3. B is going to be 3, negative 3. C is going to be 3, negative 2. And D is going to be 4, negative 1. Now you make sure that you find the images using the rule. So the first one would be 4 plus 2 is 6 to get A prime. We have 6, comma, y minus 1. Well, y is negative 3, so negative 3 minus 1 is negative 4. Okay? And now you find B prime, C prime, D prime. Make sure this is all completed by tomorrow, including the exit ticket. I'll see you guys tomorrow. Make sure that you come into class with questions if you have any. Miss